Imagine that John's just gone grocery shopping with his bicycle, but he needs to quickly use the bathroom. Unfortunately, his bike is fairly old and is missing its stand. On top of that, the handles are worn from years of biking, and are fairly delicate. The bag of groceries he shopped for has a mass of 3.21 kilograms, while the bike itself is 10.5 kilograms. Assuming the handles have a length of 0.73 meters, and the height of the bike is 1.13 meters. To protect John's bike handles, at what angle should John lean his bike such that the force exerted on the handles by the wall is 0 newtons? Assume the center of mass of the bike is halfway along its vertical axis, the bike is parallel to the wall, and that it rotates about its wheels. We can start by modeling this problem with simple shapes for the handles and the bike's vertical axis. The question asks us what angle we need to lean the bike at, so that the wall contributes no force to the static equilibrium of the bike. In other words, the torque exerted by the grocery bag's weight needs to cancel out the bike's own weight exactly. We start by finding the torque caused by the bike, which is the force or mg multiplied by perpendicular distance, which can be seen here as half the height times cosine of theta. Now, we need to find the torque from the grocery bag. In this case, the distance is a little bit different. It is calculated as the horizontal distance from the handles subtracted by the horizontal distance caused by the leaning from the vertical axis of the bike. You can see from the diagram, forgive me for its messiness, this fact. Now the horizontal distance from the handles is calculated as half the length multiplied by cosine of the angle that the handles make with the horizontal. Doing some geometry, we find this angle to be 90 minus theta, which using trigonometric identities is sine theta. The other horizontal length is fairly straightforward, just the height times cosine theta. Subtracting we get the net horizontal distance of the groceries, and that multiplied by its weight is the torque. We can cancel out g from this equation, and multiplying out the mass values and simplifying, we find that tangent of theta equals 8.17. Inverse tangent both sides and we find that theta equals 83.0 degrees.